I mute, which one I mute? Do you mute the Zoom or I mute the
No, on the YouTube.
YouTube? Okay.
Sir, we are live now. You can start.
How do you mute? I have to mute here now. Mute is not appearing anywhere here.
Sir, can you see the video started on YouTube?
Can you see this now? A lot of things appearing here. What is this?
Sir, just refresh that YouTube link once again.
Where is the thing gone actually? I see all other things coming here.
Sir, take the cursor on that screening video.
Yeah, no. This is happening now. YouTube or mute karna hai. You do that, but
Yes.
Where is the mute? Where is this one now? Where is the? I see all kind of things appearing here. Oh, I'll do one thing. I'll again rejoin. I'll rejoin again.
No, sir, don't leave this Zoom meeting. You just refresh that YouTube link.
I again join, no? YouTube, right?
Yeah.
I click on YouTube again.
Okay.
It's muted now, I think, right? That's good. Can I now?
Yes, sir, please start. We are already live.
Okay. Good evening to the participants of this course, Aqueous Corrosion and Control, offered through NPTEL. And I hope that the participants had useful lecture sessions online. And I think we have so far covered about 18 topics, starting from the thermodynamic concepts of Gibbs free energy and the electrochemical equilibrium. Then we also looked at the kinetics, then we also looked at passivation. Then we looked at things like the Courbet diagram, okay, and then the uniform corrosion. I suppose it has been useful to you. And today we are here to listen to you and find out what are the questions that you have with you. I have also seen some response sheet from one of the participants. I think, if I am not mistaken, it's Syria, I think, right? And you have asked a question regarding the waterline corrosion. You asked why the corrosion occurs at the waterline at a severe rate, why it does not appear at a very high corrosion when you have deep inside the water. They're very interesting and important questions. Now, first of all, you need to understand what you mean by waterline corrosion. The waterline corrosion is not exactly on the water-air interface. The waterline corrosion occurs just below the air-water interface. Now, at the air-water interface, the oxygen enters the water and then causes a reduction reaction. This oxygen will take away electrons, and along with water, it forms hydroxide. So the cathodic reaction here is water plus oxygen plus electron giving rise to hydroxide. So the cathodic reaction occurs at the air-water interface. Now, where does the anodic reaction occur? Now, the anodic reaction can occur from the just below the water line and then down anywhere. Now, the driving force for the anodic reaction decreases as we move from the water line towards the bottom of the tank or whatever it is. Because when you have electrochemical driving force, right? The electrochemical driving force is arising out of two reactions and their potentials. One potential is a reduction of oxygen that gives you one potentials that is relatively positive. And there is another reaction, let's say iron is dissolving as Fe2 plus 2 electrons. That is a potential. So these two, when they couple, there is an oxidation of iron and the reduction of oxygen taking place. Now, what happens when you move from the interface towards the bottom? The potential of iron going to iron 2 plus 2 electrons will remain the same. It's not going to change. But the resistance offered by the electrolyte increases if you go from the top to the bottom. So what I'm trying to say, assume that at a point much below the water line, there is anodic reaction occurs. Okay, the electrons are released. The electrons travel through the metal body and go to the surface interface, and they combine with oxygen and form hydroxide. But in the electrolytes, the ions have to travel, right? Okay, so then only the circuit is complete. So the electrolyte now offers resistance. Okay, the resistance is related to what? R equals to resistivity multiplied by the length upon the area of over which the ions are traveling. So as you start moving down, a cathode on the top surface, and as you move down, the anode is bottom, the resistance increases, and so the anodic reaction rate will decrease. So that is the reason why the anodic reaction is very effective just below the water line. So that's how the waterline corrosion occurs. I do hope that you understand. And if you have any further questions on that, please put that in the chat box. And if there are any other people who are also participating, have any other questions, please do let me know if you have any questions. The questions will appear in the Zoom, or where do appear here? Will appear in the
YouTube chat box.
the chat box in the
YouTube.
Zoom in the YouTube.
Yes, sir.
Okay, so I don't have to shuttle actually, right? Okay, so let me then wait for the any questions from the participants. Okay. Please feel free to ask questions. I don't see any questions from anyone. Okay. Do we then, if there are questions, do we consider to close this session?
Yes, sir, you can close the session.
Okay. I wait for a minute or two. If there are no questions, I think then we can close.
Okay, sir.
Okay, guys, thank you then. I think we can close the session. However, please remember, you can always, communicate your questions. We can answer that offline as well. Okay, so please feel free to contact. Okay, I do hope that the remaining the lectures will be useful for you to understand the aqueous corrosion of metals. Okay, thank you so much.
Okay, thank you, sir.
Thank you.